In this last section of Chapter 2, we'll look at inverse functions. We write the inverse of a function as f inverse of x. That -1 is not an exponent. That -1 shows that we're talking about the inverse of function f. Two functions are inverses of each other if f of g of x equals x and g of f of x equals x. It has to work both ways. So we'll see that in this next example. So here we have f of x is equal to x minus 300 and g of x is equal to x plus 300. And we want to know, are they inverse of each other? So the first thing we'll do is we'll find f of g of x. So again, this is f first, so we'll start with f, but we'll put parentheses where the x is. And then in those parentheses, because g is inside, we'll put g inside. Now those parentheses aren't doing anything because there's nothing smashed against them, so we could write it without. And we can see that if we simplify that, we would just get x. So it works that direction, and we need to check the other direction. So this time it's starting with g. So again, we would start with g, but where there's an x, we'll put parentheses. And this time f is inside, so we'll take f and we'll put it inside the parentheses. Now again, those parentheses aren't doing anything because there's nothing in front of them. So we'll just write it without the parentheses and simplify, and we can see that equals x also. Because this way equals x and this way equals x, they are inverses of each other. So let's look at this one. Here, we're going to start by finding f of g of x. Again, here's f of x, and that's what's first. So we're going to write 3 parentheses x plus 2. And in that parenthesis, we're putting g of x, so we'll put x minus 2 over 3. And we'll simplify. This 3 cancels out that 3, leaving us with x minus 2 plus 2, and that cancels out us leaving x. So let's try it the other way. Well, g of f of x means that, again, we have to start with g this time because it's in the outside. So we'll take g, we'll put parentheses where the x is, and then we'll copy the rest of it, minus 2 over 3. And then f goes inside those parentheses, 3x plus 2. And then we'll simplify. Those parentheses aren't doing anything, so we really have 3x plus 2 minus 2 over 3. Plus 2 minus 2 cancels out, so we have 3x over 3. That cancels out the 3's and just leaves us with x. So because we got x here and we got x here, the answer is yes. They're inverses of each other. We'll do one more of these. So again, we'll start with f of g of x. We'll start with f. So we're going to write our 5, and then instead of x, we're putting parentheses, minus 3. And then g of x will go inside those parentheses. So we have x plus 3 over 5. The 5's would cancel out, leaving with x plus 3 minus 3. Plus 3 minus 3 cancels out, and leaves us with just x. So we'll try it the other way. It is possible for it to work one way, but not the other way, so you do have to try them both. We'll start with g, so we'll put parentheses plus 3 all over 5. Inside those parentheses, we'll put 5x minus 3. Those parentheses aren't doing anything, so we just have minus 3 plus 3 cancels out with 5x over 5. 5's cancel out and leaves us with x. So because they both equal x, the answer is yes. So we can find inverses of a function. Inverses of a function are always about switching x and y. So if we have points, we just need to switch x and y, and we're done. That's the inverse. In equations, we replace f of x with y because they're the same thing, and we need to see that y. Then we switch x and y. Then we solve for y, and in the very end, we want to rewrite it so that we show we found the inverse, f inverse of x. So we'll practice that here. First of all, f of x is the same thing as y, so we'll write y equals 7x minus 1. Then we'll switch x and y, so we'll write x equals 7y minus 1. And then we'll solve for y, so we'll add 1 to both sides. That gives us x plus 1 equals 7y. And then we divide both sides by 7. And that gives us y equals x plus 1 over 7. So then we just need to write that as an inverse. So we write f inverse of x equals x plus 1 over 7. So again, we'll do the same thing here in example 5. We have y equals x cubed plus 4, so we're just replacing f of x with y to begin with. And then we'll switch x and y. So we get x equals y cubed plus 4. And then we'll solve that, so we'll subtract 4 from both sides. That gives us x minus 4 equals y cubed. To get rid of the y cubed, the cubed part, we need to take the cube root of both sides. And that's what cancels out that y. So that gives us y equals the cube root of x minus 4. And then finally we just write it as the inverse. F inverse of x equals the cube root of x minus 4. So we'll do one more of these. We'll start by rewriting it with a y. Y equals 3 over x minus 5. We'll switch y and x. So we get x equals 3y minus 5. We'll add 5 to both sides to start getting y by itself. So we get x plus 5 equals, that cancels out 3 over y. Now y is in the denominator, which makes it a little bit harder here, a little bit more steps. We have to put this x plus 5 in parentheses, and then we'll multiply both sides by y, because here 3 is being divided by y. Opposite of division is multiplication. So that leaves me, and I just want to leave the left side as it is. It leaves me with y times x plus 5 equals 3. But I really want that y by itself, so I'm just going to divide by the x plus 5 on both sides. That's going to cancel out over here. And that leaves me with y equals 3 over x plus 5. And then I would just write it as an inverse. F inverse of x equals 3 over x plus 5. So not every function has an inverse. A function has an inverse if it is 1, 2, 1. So that means that each x only goes to 1y and each y only goes to 1x. On a graph, we can see this quickly by using the horizontal line test. So just remember, you have to keep this straight. The vertical line test tells us if it's a function. We did that in 2.1, the very beginning of the chapter. The horizontal line test tells us if it has an inverse or if it's 1 to 1. So this question says, is f of x equals x squared 1 to 1. So remember, this is just the graph of y equals x squared. And we know how to graph that. We know it looks like this. Okay, it is a function, remember, because it passes the vertical line test. So now we're going to check to see if it's 1 to 1. But if I can draw a horizontal line and it crosses in more than one spot, it's not 1 to 1. And if it's not 1 to 1, it does not have an inverse. If it is 1 to 1, it does. So now we're supposed to graph this function and tell whether it has an inverse. So this is our square root function. Remember, it would do something like that. But this minus 3 inside would move it right 3. So now our function is really here. That's our graph for this one. And if we check it with a horizontal line, it doesn't cross that graph in more than one spot. There's no place where a horizontal line would cross that graph in more than one place. So it's 1 to 1, and that means yes, it has an inverse. So remember again how we start with this graph. This is an absolute value graph, and it would go something like that. This minus 1 inside would be right 1, so that moves the graph to here. So that's our graph, and if we can draw a horizontal line in any one spot and it crossed that graph in more than one spot, it's not 1 to 1, and it does not have an inverse.